Hello, this is Mr. White. We're on Chapter 16, and this is Lesson 5, The Outer Planets. My Planet Diary. Predicting a Planet. In the 1840s, astronomers were puzzled. Uranus didn't move as expected, based on the theory of gravity. Astronomers John Couch Adams and Urbain Le Verrier independently hypothesized that Uranus was being affected by another planet's gravity. They calculated that where this planet should be. Another astronomer, Johann Galle, aimed his telescope at the place Le Verrier predicted. On September 23, 1846, he discovered the new planet, Neptune. What do the outer planets have in common? If you could visit the outer planets, you wouldn't have a solid place to stand. The four outer planets are much larger and more massive than Earth, and they do not have solid surfaces. Because these four planets are so large, they are often called gas giants. Figure 1 summarizes some basic facts about the gas giants. Composition. Jupiter and Saturn are composed mainly of hydrogen and helium. Uranus and Neptune contain some of those gases, but also ices of ammonia and methane. Because they are so massive, the gas giants exert a very strong gravitational force. This gravity keeps gases from escaping, forming thick atmospheres. Despite the name gas giant, much of the material in these planets is actually liquid, because the pressure inside the planet is so high. The outer layers are extremely cold because they are far from the sun. Temperatures increase greatly within the planets. Moons and rings. All the gas giants have many moons, ranging from 13 around Neptune to more than 60 around Jupiter. These moons vary from tiny balls of rock and ice, barely a kilometer across, to moons larger than Mercury. Some of these moons even have their own atmospheres. In addition, each of the gas giants is surrounded by a set of rings. A ring is a thin disk of small particles of ice and rock. Saturn's rings are the largest and most complex. What are the characteristics of each outer planet? Since telescopes were first invented, scientists have studied the features of the outer planets and their moons. Today, space-based telescopes and space probes, including the Voyager, Galileo, and Cassini missions, have revealed many details of these planets that are not visible from Earth. Scientists are constantly discovering new information about these planets and their moons. Jupiter. Jupiter is the largest and most massive planet. Jupiter's enormous mass dwarfs the other planets. In fact, its mass is about 2.5 times that of all other planets combined. Jupiter's atmosphere. Like all of the gas giants, Jupiter has a thick atmosphere, made up mainly of hydrogen and helium. One notable feature of Jupiter's atmosphere is its Great Red Spot, a storm that is larger than Earth. The storm's swirling winds are similar to a hurricane, as you can see in Figure 2. Unlike hurricanes on Earth, however, the Great Red Spot shows no signs of going away. Jupiter's structure. Astronomers think that Jupiter probably has a dense core of rock and iron at its center. A thick mantle of liquid hydrogen and helium surrounds this core. Because of the weight of Jupiter's atmosphere, the pressure at Jupiter's core is estimated to be about 30 million times greater than the pressure at Earth's surface. Jupiter's structure. Astronomers think that Jupiter probably has a dense core of rock and iron at its center. A thick mantle of liquid hydrogen and helium surrounds this core. I just read that. Jupiter's moons. The Italian astronomer Galileo Galilei discovered Jupiter's largest moons in 1610. These moons, shown in Figure 3, are named Io, Europa, Ganymede, and Callisto. Since Galileo's time, astronomers have discovered dozens of additional moons orbiting Jupiter. Many of these are small moons that have been found in the last few years, thanks to improved technology. Saturn. The second largest planet in the solar system is Saturn. Saturn, like Jupiter, has a thick atmosphere made up mainly of hydrogen and helium. Saturn's atmosphere also contains clouds and storms, but they are less dramatic than those on Jupiter. The Cassini space probe found unusual six-sided cloud patterns around Saturn's north pole. Scientists aren't sure what causes these patterns. Saturn's rings. Saturn has the most spectacular rings of any planet. These rings are made of chunks of ice and rock, each traveling in its own orbit around Saturn. From Earth, it looks as though Saturn has only a few rings, and that they are divided by other narrow, dark regions. Space probes have shown that each of these obvious rings is divided into many thinner rings. Saturn's rings are broad and thin, like a compact disk. Some rings are kept in place by gravity from tiny moons that orbit on either side of the ring. Saturn's moons. Saturn's largest moon, Titan, is larger than the planet Mercury. It is also the only moon in the solar system that has a thick atmosphere. The atmosphere is composed mostly of nitrogen and methane. Some of these gases break down high in the atmosphere, forming a haze that is somewhat like smog on Earth. In 2005, the Huygens probe landed on Titan's surface. Photos from Huygens show features that may have been formed by flowing liquid. A few scientists think that Titan might support life. Scientists have learned a great deal about Saturn's moons from the Cassini space probe. Giant craters and trenches cut across Mimas and Tethys. Ice and water erupt in geysers from the surface of Enceladus. In 2009, scientists discovered a ring of material that may come from the outermost moon, Phoebe. Figure 4 shows some members of the Saturn system. Uranus. Although the gas giant Uranus is about 4 times the diameter of Earth, it is still much smaller than Jupiter and Saturn. Uranus is twice as far from the Sun as Saturn, so it is much colder. Uranus looks blue-green because of traces of methane in its atmosphere. Like other gas giants, Uranus is surrounded by a group of thin, flat rings, although they are much darker than Saturn's rings. Uranus's moons. Photographs from Voyager 2 show that Uranus's 5 largest moons have icy, cratered surfaces. The craters show that rocks from space have hit the moons. Uranus's moons also have lava flows on the surface, suggesting that material has erupted from inside each moon. Voyager 2 images revealed 10 moons that have never been seen before. Recently, astronomers discovered several more moons, for a total of at least 27. A tilted planet. Uranus's axis of rotation is tilted at an angle of about 90 degrees from the vertical. Viewed from Earth, Uranus rotates from top to bottom instead of from side to side, as other planets do. You can see the tilt in Figure 5. Uranus's rings and moons rotate around this tilted axis. Astronomers think that billions of years ago, an object hit Uranus and knocked it onto its side. Images from Voyager 2 space probe allow scientists to determine that Uranus rotates at about 17 hours. Neptune. Neptune is similar in size and color to Uranus. Neptune is a cold, blue planet. Its atmosphere contains visible clouds. The color comes from methane in the atmosphere. Neptune's interior is hot due to energy left over from its formation. As this energy rises, it produces clouds and storms in the atmosphere. Neptune's atmosphere. In 1989, Voyager 2 flew by Neptune and photographed a great dark spot about the size of Earth. Like the Great Red Spot on Jupiter, the Great Dark Spot was probably a giant storm, but it didn't last long. Images taken 5 years later showed that the spot was gone. Neptune's moons. Astronomers have discovered at least 13 moons orbiting Neptune. The largest moon is Triton, which has a thin atmosphere. Voyager 2 images show that the area of Triton's south pole is covered by nitrogen ice.